Hello, today we are at Piter Pi and Golang conference at St. Petersburg. My name is Vitaly and I'm a program committee of Piter Pi, and today we will talk with Johan. Hello Johan, could you please tell us who are you, where you're working, where you're from, and say us a little what was your talk about in maybe 1 or 2 minutes.
Okay.
You're welcome.
I'm Johan. I'm from Sweden, but I live and work in the UK. And my talk was about automating certificate distribution with TLS. Mm-hmm. And I work at a company called Utility Warehouse, where I write Go applications, just microservices, the kind of normal stuff that you use Go for, Kubernetes, grpc, that kind of stuff.
Is it a big company? How much employees?
We have about 200 engineers, I think, and so we have about 3 million customers in the UK, so quite a few customers.
That's nice.
So we work with utilities, so we provide energy and water and things like that to customers, but we're not really like the provider itself. We just provide a service whereby our customers can pay one bill and they got all of the energy, broadband, water, house insurance, all of that under one roof. That's a service we provide.
And you make an accounting of all that services? Right?
Yes, exactly.
Okay. Could you please describe in some words about, so you said the title of your of your talk. Could you please describe more details about
a little bit more specifically, when you're working with large service deployments internally at companies, normally you will want to encrypt the traffic between services. Mm-hmm. So the current best way of doing that is to kind of manually create certificates either by using an internal certificate authority and having that issue certificates for you on a regular interval or something like that. But I was presenting an alternative solution using some software that I've written called Certify, which is a library that plugs right into the Go TLS stack. So you just create a little struct in your Go application, and you plug that into your service, and it automatically creates certificates for you, so that you can authenticate clients using their certificates and authenticate the server using the certificate as well.
Could you please, so the purpose of creating these certificates to communicate between services is that they communicate some in external internet, that
no, not really.
It's secured?
Yeah.
Because mostly it's just they have some DMZ that's...
This is kind of the old way of thinking about things.
Yeah.
The idea of that we have a secure internal network where we can use unencrypted traffic, etc. That's kind of going away in the modern application development. Companies like Google have been doing this for a decade already, but Google kind of work a little bit step ahead of most people anyway. Yeah. But a lot of companies now are looking at having kind of encryption as another layer of protection. So even internally, you may not want even like a rogue employee to be able to kind of snoop traffic. Mm-hmm. So you have encryption and you make sure that it's only visible to maybe like an administrator or something like that. So that's just another layer in the stack, ensuring that your traffic and your customers' data is safe.
Yeah. Security is never enough.
Exactly, it's never done either, and you're never safe. You can do your best to mitigate the dangers.
I think that the most problem in any security is people. So, but we're trying to secure by technologies, but
yeah, that's true. Yeah, it's the best system is the one that doesn't have to run at all, I think. But if you have to run something, then you're already compromising.
The system that's plugged into internet. So
yeah, exactly.
You just unplug it.
Yeah, no, that's people. Even air-gapped systems nowadays, you can do things like if you have a microphone, even listening on the other side of a wall, you can sometimes just by reading the sound that a CPU makes when it's decrypting private keys, you can sometimes extract the data from that. It's insane. Like the things that attackers can do nowadays. You can't hope to have perfect encryption. You can only hope to make the best precautions that you
can. So try to make best and to have less possibilities to...
Yes.
That's nice. How long are you coding Go? And it's a very... it's not very old language. It's pretty young.
Yeah.
And what was before the Go and why you have moved?
That's an interesting question, actually, especially knowing where you come from. I've been doing Go for about 3.5 years, and before that I was doing a lot of Python.
Oh.
Yeah. So I was doing Python for about 2 years. I really like these signals.
Yeah, it's kind of in theater, two rings, so you should go and listen to the talks.
Okay, so I was doing a lot of Python actually. mostly Python 2, a little bit of Python 3 as well. It was about the time that 3.4 was coming out, and I was learning about async I/O and things like that. And I know async I/O, I never really wrapped my head around. I think that's really complicated. I really like Python for how kind of easy it is to use, but the problem for me with Python was that as you scale up your applications and you get more contributors, it becomes really hard to maintain. I know nowadays you can use type annotations to help kind of get better type information into your system, which is something that I was lacking at the time. So I'm really excited to see that being deployed more in the Python world.
So typing is something you have missed in Python and decided to.
I don't want to slight Python here because I understand that the Python conference is bigger than the Go conference.
There are more people of Python than Go.
You're on the Python program committee, so I know you must love Python. But for me, I used to write kind of CLI applications in Python because you can get something done so quickly. But then I wrote my first one in Go, and I tried to go back to Python, and I felt, where are my types? So yeah, that was the experience for me.
Okay. I know that many people are going from Python to Golang, so it's that's the key. And
they have kind of similar philosophies, I think, just making it easy, keeping it simple. So that's it's really attractive, I think.
Yeah, and as you said, typing, and they have some kind of code style out of the box.
Yeah.
And that's good, not just you use PEP.
I don't know, PEP 8 is an extension. It's not been accepted, is it? PEP 8 isn't all agreed on either, is it? There's like all different kinds of, what different formatters are there? There's a Go format, there's a Google formatter called yet another Python formatter. Yep.
Yeah, there are a lot of them.
There's a lot of formatters, yeah.
Yeah, so and we have talked with previous speaker, and he said there is something that Go have created better integration to create linters for Go.
Yeah, that's true. Yeah, the Go ecosystem around tooling is very good. So it's, I mean, Python is very good as well because it's had such a long time to develop this. But in Go, you can use the standard library packages to parse, and it has these kind of integrations where you just define basically the business logic of your tool. So that's really helped the Go ecosystem flourish with all these tooling that exists. Now, I mean, when you were using an editor just 6 months ago, you would be using kind of 10, 12 different Go packages. So one of them was responsible for Go to definition, and one of them was responsible for finding uses of this function or whatever. Nowadays, we try to move to the Go language server, which is, I think, something that's probably being worked on in Python as well. I'm not so sure in this area, but the language server is kind of taking all of that and putting it all into one place. And it's being worked on by people at Google, so I'm really excited about that as well.
Oh, that's nice. And I have some question that have a lot of holy wars inside the community. What do you think about generics in Go? Should they be
that's
there
a great question. So personally, I think I probably wouldn't end up using generics in Go. I would be excited to see generics in Go, but I am worried that generics would make it harder to read some code, because I think one of the real strong powers of Go is that you can, if you want to answer the question of how does this library really work, you can just dive into the source code. And because Go is such a limited language, because let's face it, it's very basic. Like it's not Haskell, it's not Rust,
not Java.
It's not Java, it's not even Python. Like Python has some really interesting high-level abstractions, but Go is so basic. You can go in there, you can just read the code, and often it's just dumb for loops or whatever, and you just understand what it is. But if you look at the generics proposal, then all of a sudden there's this extra set of brackets, and the type information isn't there, it's abstracted, and you're like, whoa, this is really hard to understand. So on the one hand, I'm really excited because it will allow us to solve problems that we're not really able to solve well at the moment, like the data abstractions. But on the other hand, I'm worried what people will do with it. Like this is great. With great power comes great responsibility, and I think the Go community has been very good at being kind of cautious. We haven't been using empty interfaces everywhere, which is a way of doing generics nowadays. So I'm hoping that the Go community will rally around generics in a productive way and try and kind of limit the absurd uses of generics that exist.
The simplicity of the language.
Keeping it kind of on the down.
As it's strong parts of the Go, keep the strong parts of the Go.
Exactly, Keep Go in some way.
Yeah, that's nice. Could you please, we at the end of the year, so could you please say what's impressed you most this year?
Ooh, interesting.
Not only maybe in Go technical part, or maybe something happened in the world.
Oh, I've been really excited with the WebAssembly this year. I gave a presentation in Paris, and it's been exciting to see WebAssembly kind of develop both within Go, but also generally within the tech system. Like Rust does really exciting stuff around WebAssembly.
Have you tried Rust?
I have not really. I tried it for like a weekend and I got nowhere, which I guess says something about Rust, or maybe it says something about me. But it's something I want to learn because I think it gives you a better understanding of how you write code in other languages as well.
And what do you think about functional languages like, I don't know, Haskell or Lang?
I want to learn Haskell to understand functional paradigms better. But I kind of started looking into Elm. Have you heard about Elm? Yeah, the kind of front-end functional programming language. I've heard that's a good entry point for functional programming. I think on the one hand, functional programming is something that is never going to be mainstream because it is somewhat difficult to understand or somewhat difficult to explain. And I know I have worked with a lot of functional programming evangelists, and they always say, oh no, if you just study it from the beginning, it's super basic, like I'm dumb and I know what to do, like how to use it. But it's not. It's like, and also it doesn't really map onto CPUs very well. Like you can write a program in Haskell that's like this beautiful. Have you seen a quick sort in 5 lines in Haskell or something like that? It's like beautiful academically because you've defined this kind of complicated algorithm with 5 lines of Haskell. But when you run it, it's completely useless because it uses like O(n) squared memory space or something like that. So it's like not practical. It's very interesting to learn about, but I don't know if it's ever going to be practical.
Yeah, I think it's Haskell is something for the guys with I don't know, university high degree.
Exactly. Yeah, no, but it also helps kind of usher forward new advances in language design. So Rust obviously has some inspiration from Haskell, but Rust is a much more practical language. Like with Rust, you can get things done. Rust is amazing performance, rivaling or even beating C in some cases, which is the benchmark for performance, right? So Rust it has Haskell to thank a lot, I think, for some of the ideas in Rust. Many new languages are inspired by good practices from other languages, and I think Rust is one of them that took a lot from some languages, maybe a good part from C++ and the memory handling from some I don't know functional languages where the memory parts are immutable, so you cannot change the variables. You just have if you want to change variable, you create a new one. So it helps to better handle some problems with memories and many problems that I don't know Java has. Okay, Johan, thank you very much. Could you can say something to our watchers, maybe in a few words? Okay, I'm really grateful to be here in St. Petersburg. Okay. I'm really grateful to be here in St. Petersburg, and I'm really excited to see the city. And it's been a fantastic welcoming from the people here so far. And thank you for having me.
Thank you very much.
Thank you, Vitaly.